For this practice, we implement a basic transistor circuit to ensure that no matter the load that we connect in it, it will provide and consume the same amount of current, and that is 127 microamps, and maintaining in the 80 decibels area and have the transistor operating in the active region. The component that we use is the Zener diode that is in reverse, since in that way it lets us work with the current would pass for our transistor, and thus be able to carry on this practice and meet the object that is completed.
Okay, so we decided to modify the nominal voltage of this Zener diode to 5.6 volts. And well, now we needed to calculate the emitter resistance, which is obtained by the voltage at the base minus the voltage at the base emitter. The voltage at the base is 5.6 volts, and we then subtract 0.7 volts, which is the voltage at the base emitter, and then we divide all this by the current at the load, which is the current that we want, 127 microamperes. After all this, we obtain a emitter resistance of 38 kilo ohms, but since we are asked to use commercial values, we did not find commercial value that it was close enough to 38 kilo ohms. So what we did instead was connect two resistors in series, one of 12 kilo ohms and another one of 27 kilo ohms, in order to have this summed up and obtain the 38.9 kilo ohms.
Then we passed to be ensured that we were working in the active region for this transistor. So the first thing that we do, we connect an amperimeter into the base of the transistor, and we calculate the current in the base. So then we calculate the beta of the transistor, the gain, by dividing the current in the collector by the collector in the base. That gives us 300 approximate, and we are going to be ensured if the current of the base times this beta is equal to the current of the collector. And when we do the calculations, we get the same values by multiplying the 0.43 microamperes by 300. That gives us approximate 127 microamperes.
Okay, as Pablo said, we observed that the maximum operational current of a Zener diode it's working at 5.6 volts and 134 milliamps. So we decide the value of the resistance ones that don't exceed the amount of the current. The value of the resistor one is 510.
So then we observe that if we modify the resistance one into a very low resistance, maybe 1 ohm, the total of amperes that we have was 7 amperes. So if we pass those current into the diodes are not going to work, and that's going to be a problem. So we need to ensure that we are working in a current that the diode can supply. And finally, in order to ensure that our constant current source was working well, we start to modify the resistance in the load, and we can see that if we vary the resistance in the load, the collector current doesn't change. And that
was it
for this practice.
Thank you.
Thank you.